All right, we're going to walk you through section 10.6. It's a word problem section, and there's a lot of different ways we could do word problems with you, and we're just trying to focus on one particular thing, and we're looking at rectangles, squares, and their area. So we assume you remember from middle school that the area of a rectangle is length times width, and even if you didn't remember it, it's an easy enough thing to kind of pick up. And so we have here, it says a rectangle has a length of 4 inches shorter than its width. Let x represent the width of the rectangle. So we can kind of make a rectangle here. All right, we'll call this the width, and that says that that's x, and we're told that the length of the rectangle is 4 inches shorter. So whatever x is, this is going to be 4 less than this. So if this was 10, this would be 6. If this was 30, this would be 26. Whatever this is, we're going to take that value and subtract 4 from it. So the expression for the length of the rectangle would just be x minus 4. All right, so that takes care of that. Then it says write an expression for the area of a rectangle. And again, the area of a rectangle is just its two sides multiplied together. So we're going to take x times x minus 4, and that's our area. Now, if you wanted to distribute that and make it x squared minus 4x, that's fine too. But in terms of writing an expression for the area, that would get the job done. Okay, and then it says the area of the rectangle is 21 square inches. Can we write an equation and find these side lengths? So if the area is x squared minus 4x, and we're told that it's 21, we're going to set that equal to 21, and then we'll go ahead and subtract 21 from both sides, bring it over to here, and now we have a quadratic just like we've been solving. So we're looking for two numbers that multiply to equal negative 21 and add to equal negative 4. That would be negative 7 and positive 3. So that means x equals 7 or negative 3. Now, remember, x represented originally the width of our rectangle, so we can't have a width that's negative. That doesn't make any sense. So we're going to get rid of that answer, and we're going to say that it has a width of 7. And then the length of the rectangle we were told was 4 less than that, so 4 less than 7 would be 3. So now you could have probably done a little trial and error and just kind of thought your way to 7 and 3, and that's fine, but this gives you an idea of how to use the quadratic to kind of work our way to an answer. If that hadn't been factorable, maybe we could do completing the square or quadratic formula to get those side lengths in a way that you wouldn't be able to do just in your head and stuff. So it shows you just a little bit of what we can do with it. I'm going to give you another one here. This one says we have a square that has side lengths of x centimeters. So obviously a square has sides that are exactly the same length. Okay, so there's our original square. And so we're told that one side is going to be lengthened by 10 centimeters. So this is the square that we started with. So what we're going to do is we're going to take one of these sides and we're going to add 10 centimeters to it. Okay, and then the other side is shortened by 8 centimeters. So we're going to take the other side, we're going to make it a lot smaller. We're going to make it x minus 8. And so this gives us a new rectangle, all right, where one side has been jacked out 10 and one has been shortened by 8. All right, so A says write an expression for the area of this rectangle. Well, again, it's just these two sides multiplied together. So the short side and the long side multiplied together gives us an expression for the area. Okay, the new rectangle has an area of 40 square centimeters. Can we write an expression for that and find the lengths of the sides? So we're going to take our two things here, x minus 8, x plus 10, and set that equal to 40. Now, this one's going to be a little unique in that we're going to have to multiply this out and then subtract the 40 over. So you might go back to a little bit to when we multiplied. Either we can take the first term times each of these, then the next term times each of them, or you can build that magic square here and have x minus 8 and x and 10. You can do it whatever way you want, but for me, I'm just going to go x times x is x squared, then x times 10 is 10x. Then I go to the negative 8. Negative 8 times x is negative 8x. Negative 8 times 10 is a negative 80. Okay. And then we're going to do two things here. We're going to put these two together. So 10x minus 8x is 2x. And then when I subtract 40, negative 80 minus 40 is going to be a negative 120. So again, I'm just taking the negative 80 here and I'm minusing 40. So you can kind of see it like that right there. Okay. Now, once I get to here, I'm thinking about two numbers that multiply to equal negative 120 and add to equal 2. And those numbers are 12 and negative 10. 12 times negative 10 is negative 120. 12 plus negative 10 is 2. So this gives me x equal negative 12 or 10. Now again, we got to understand what these numbers were supposed to be solving for. They're supposed to be solving for the side length of a square. So I can't have a side of negative 12. That doesn't make any sense. So my side originally must have been 10. Okay? So then when you think about what happened, we took that 10 and we subtracted 8. So that gave us a side length of 2. And then we added 10 to it, and that gave us a side length of 20. 20 times 2 is 40, and that works out with what we had originally. So the lengths of the rectangle are 2 and 20. And then the last question says, well, what was the area of the original square? The original square had a side length of 10. So 10 times 10 is 100. So that would be our original area. Right? So it kind of gives you an idea, but sometimes a picture is the best thing you can do. Just draw it real quick, and that helps kind of set everything up for you and whatnot. But anything you might see on a quiz or a test is going to look something like these two problems that we just did together.